Welcome to this GCSE Science tutorial video on energy stores and systems. For great GCSE Science content, be sure to subscribe and remember to check us out on TikTok, where we post GCSE Science videos daily. Energy is the ability to do work. All objects have an energy store. There are 8 energy stores. And energy is always transferred between these stores. The 8 energy stores are the kinetic energy store, found in any object that moves. The chemical energy store, found in chemical bonds. Food and fuels are stores of chemical energy. Next, we have the magnetic energy store, which is found in magnetic objects such as iron, cobalt, and nickel. And these magnetic objects can attract and/or repel. Another energy store is the nuclear energy store. This is where energy is released during radioactive decay via the processes of fission or fusion. Our next energy store is the elastic potential energy store, found in stretched or compressed material. For example, springs or elastic bands. Next, we have the electrostatic energy store, found in electric charges, positive or negative, that are attracting or repelling. It is protons that are positively charged and electrons that are negatively charged. And when atoms lose or gain electrons, they can form ions, charged particles. The 7th energy store is the thermal or internal energy store, found in any object above 0 Kelvin or minus 273.15 degrees Celsius. This temperature is the coldest known temperature in the universe. It is known as absolute zero. Lastly, we have the gravitational potential energy store, found in objects at a height. Another way of saying this is an object's position in a gravitational field. One important thing to remember about energy is that there's a fixed amount in the universe. The law of conservation of energy states that energy cannot be created or destroyed, but only transferred usefully or dissipated. The word dissipated simply means spread into the surroundings. Energy transfers always take place in what physicists call systems. A system is an object or a group of objects. An example of an object could be a ball. An example of a group of objects could be two cars colliding with each other. And if you change a system, it means energy has been transferred. Either away or into it. And this energy is transferred between energy stores. Systems are described as being open or closed. Open systems are in direct contact with the surroundings, so energy and matter can escape. A closed system is a system in which energy or matter cannot escape. Therefore, the overall or net energy change is zero. Examples of open systems are open coffee cups or an open bottle of water. However, examples of closed systems would be a coffee cup with the lid on or a closed water bottle. However, in reality, no system is ever completely closed. Our coffee cup, even with the lid on, will not remain hot forever. Thermal energy will eventually dissipate. It just helps us to understand systems better by describing them as being open or closed. So how then is energy transferred between stores? Well, there are four mechanisms by which energy can be transferred between stores. They are by radiation or waves, so electromagnetic waves or light and sound waves. Energy can also be transferred electrically via moving charges, also known as electrons. Our third mechanism of energy transfer is via heating, and this will take place when there is a temperature difference between objects. The fourth and final mechanism of energy transfer is when energy is transferred mechanically. This is when a force is exerted on an object. This can also be described as work being done on an object. You have to be able to describe all of the changes to energy stores and the way in which energy is transferred within a system in common everyday situations. The first example we have here is when an object is projected upwards. For example, when a ball is thrown into the air. So when this ball is thrown up into the air, the mechanism by which the energy is transferred is mechanically by a force being exerted on the ball. And this makes the ball go up into the air. Now let's describe the energy transfer going on here. The energy transfer is from the chemical energy store of the thrower's arm muscle to the kinetic energy store of the thrower's arm and the kinetic energy store of the ball. And also the gravitational potential energy store of the ball, because the ball gets higher. A second everyday scenario is when an object collides with something stationary, an obstacle. An example of this would be a car crashing into a wall. Again, just like the first example, the mechanism by which energy is transferred here is mechanically by a force exerted by the car on the wall. Also, the wall exerts a force on the car. These are normal contact forces. Let's look at the energy transfers going on in this system then. First of all, we have energy being transferred from the kinetic energy store of the car to the elastic potential energy store of the car and the wall, as there would be some rebound. There would also be some energy transferred to the thermal energy store of the car and to the surroundings. And also, apologies, I haven't written it down here. There would also be some energy dissipated as sound waves, because obviously a car crashing into a wall would make a lot of noise. And our third scenario is an object being accelerated by a constant force. Here we have a skydiver or skydivers jumping out of a plane. The mechanism by which this energy transfer is taking place is once again mechanically by a force, and it's the force of gravity. The force of gravity is causing the skydivers to accelerate down towards the centre of the Earth. Now let's look at the main energy transfer. The main energy transfer here is from the gravitational potential energy store of the skydivers, this being a particularly large store because the skydivers are up so high, to the kinetic energy store of the skydivers as they accelerate. Next up, we have an example of a vehicle slowing down, in this case a bus. The mechanism of energy transfer, again here, is a force, but it is a frictional force between the brakes and the wheels of the bus, and also the wheels and the road. The main energy transfer that takes place here is from the kinetic energy store of the wheels or the bus itself to the thermal energy store of the surroundings, in this case the air. And this is because thermal energy will dissipate due to the frictional forces that are being exerted. So our last example here then is the boiling of water in an electric kettle. The mechanism of energy transfer here, well, we actually have two. First of all, it is electrically, and then heating via heating. The energy is transferred electrically through the wires to the heating element within the kettle, and then by heating from the heating element to the water. And now for the main energy transfer, which is from the thermal energy store of the heating element to the thermal energy store of the water. And as this happens, the temperature increases and the water will eventually boil when it reaches 100 degrees Celsius. That is the end of the video. Thank you for choosing Genius Science, and remember to work hard, be kind, and we'll see you in the next video. Take care.